Imagine a skyscraper swaying violently during a massive earthquake and not collapsing. Sounds impossible, right? Yet engineers around the world are turning this science fiction scenario into reality. Today, we're diving into the groundbreaking technologies that are making our cities stronger, smarter, and unshakable against nature's fiercest forces. Earthquakes don't discriminate. One moment, life is normal. The next, entire neighborhoods crumble. Take, for example, the catastrophic quake and insert recent major earthquake if available. If not, use 2011 Tohoku earthquake. Thousands of lives were lost, and infrastructure worth billions was destroyed. Now, imagine a world with denser, urban centers, taller skyscrapers, and millions living in seismic zones. The stakes have never been higher. The central question becomes, can we truly build structures that laugh in the face of nature's fury? Enter the marvels of modern seismic engineering. First, base isolation systems. Think of it like placing a building on roller skates. During an earthquake, instead of shaking violently with the ground, the building gently glides, absorbing the impact. Next, damping technologies like tuned mass dampers. Huge pendulums inside skyscrapers swing in the opposite direction of the quake, counteracting the sway. And viscous dampers, they act like shock absorbers in your car, reducing movement and stress. We were also seeing smart materials come to life. Self-healing concrete that can repair its own cracks, and shape-memory alloys that remember their original shape, snapping back after stress. These materials don't just survive. They adapt. Engineering isn't just about materials. It's geometry and data. Innovative structures like diagrids and outrigger systems distribute forces efficiently, giving buildings extraordinary stability. And thanks to computational modeling and AI, engineers can simulate thousands of earthquake scenarios before a single brick is laid. Real-time sensor networks monitor every vibration, ensuring proactive maintenance before minor issues become major failures. Some structures already showcase this brilliance. Taipei 101, one of the tallest buildings in the world, houses a 660-ton tuned mass damper, a giant pendulum that stabilizes the building during quakes and typhoons. Meanwhile, new skyscrapers under construction are integrating base isolation, smart materials, and AI-driven design from day one. Compare that with older buildings in the same zones, and the difference is staggering. One sways gracefully, the other collapses. The future of seismic engineering goes even further. Researchers are exploring seismic metamaterials, structures that can redirect seismic waves away from buildings entirely. But it's not just about saving lives. Earthquake-proof buildings preserve economies, protect cultural landmarks, and give communities the confidence to grow in risky zones. The race is on, and engineers are winning. This is human ingenuity at its finest, pushing the limits of science to protect lives, cities, and dreams. The skyscrapers of tomorrow won't just touch the sky. They'll stand tall, unshaken, and unstoppable, no matter what the Earth throws at them.